Carb, what's wrong? You should be happy you caught your Jaegers today. Is your ankle bothering you again?
No. I know my Jaegers were good. I'm really stressed about the prom. No one wants to ask me.
Maybe one of the guys from the gym will ask you.
Maybe Vincent.
I didn't know.
I don't want to go with just anyone to prom. I want to go with Ryan Hornung.
Oh yeah!
We know you're in here. He won't go with you. He's too into school, hockey, gymnastics, and he's smart, unlike you.
Don't worry about Allie. I can teach you all sorts of things about bonding so you can have some real chemistry with Ryan.
Okay, let's start with ionic bonds. The first thing you need to know is that they are an attractive force between two oppositely charged ions.
Yeah, Carb, you and Ryan are oppositely charged in the head.
And ionic bonds form between metals and nonmetals. Here you can see that the electrons on the calcium ion are stolen by the chloride ion, forming calcium chloride. Oh yeah, that's like the stuff they put on the roads that's like salt during the winter. Yeah! Do you guys know anything else that forms an ionic bond? Carlina?
Chalk?
Correct! Chalk is really magnesium carbonate. Magnesium is metallic, and the carbonate is a polyatomic ion that is nonmetallic. The carbonate steals the electrons from magnesium, forming an ionic bond. Next we'll discuss metallic bonds, otherwise viewed as the sea of electrons. In metallic bonds, the nucleus of an atom is generally stationary and the electrons are mobile. The electrons flow through the metal as fast as room is spread at Hampton.
So does this mean that this trophy is made out of metal?
I'm glad you asked, Tay. First, you want to see if it's ducked out or able to be stretched into a wire. Secondly, you want to see if it's malleable. Can you hammer it into a different shape? Thirdly, you want to ask if it has conductivity. Can it transfer heat or electricity? And lastly, is it shiny or lustrous, like a ring that you would wear on your finger? I think it's safe to say that this thing is plastic. The third type of bond is a covalent bond, which is between two nonmetals. And here you can see that each electron from the hydrogen is shared with the carbon. At times like this, I like to think of Hannah Montana's song, True Friend, because the electrons are sharing with one another.
You're a true friend!
Sometimes in covalent bonds, the atoms share so well, and they become coordinate covalent bonds. Here you can see that the one atom shares both of its electrons.
Yo, Carb, do you feel any smarter yet?
Not really.
Well, I think we should go to the mall anyways, just so you can get a dress. Yeah. So you're prepared?
Well, I just want some food, so let's go.
This song is Akka awesome! You know what else is Akka amazing? The octet rules, of course. Every atom wants 8 electrons in their valence shell to be stable. Hydrogen, helium, and lithium want 2 electrons in their valence shell. Beryllium wants 4 electrons, and boron wants 6 electrons.
Wow, this salad's really filling me up. I bet there's a lot of energy in there.
Did you guys know that there's a cool way that you can quantify the energy in an ionic bond using Coulomb's law? So cool! So K is the constant 8.99 times 10 to the 9 joules per meters over C. Q and Q are both the electric charges on the ions, and R is the distance between them. But Carlina, really the only thing you need to know is that the energy within an ionic bond depends on the distance between the two ions.
If you really want to impress Ryan, you don't really need to know the amount of energy in an ionic bond.
Honestly, I think I just need to show him that I'm a good time.
Yeah, let's take some selfies.
Now what Carlina didn't know was that her selfies can be related to resonance descriptions, which is a still photo of all the possible electron arrangements. There are multiple ways to draw the Lewis diagrams for some molecules, similar to multiple different selfies of the same person. A delocalized bond is similar to an action shot.
It is one photo, but you can tell that the object is moving. This is shown through dotted lines in a Lewis diagram.
I'm a Barbie girl in the Barbie world. Life in plastic, it's fantastic. You can brush my hair, undress me everywhere. Imagination, life is your creation.
Come on, Barbie, let's go party.
I'm a Barbie girl in the Barbie world. Life in plastic, it's fantastic.
Boy, all this shopping's really wearing me out.
Did you know you're drinking a polar covalent bond? This is due to electronegativity. The oxygen has the ability to pull the electrons that are within the bond towards itself because it is higher in electronegativity.
Maybe, just maybe, I should be a little more electronegative to draw Ryan closer to me.
Especially on that dance floor. Now, dancing can be related to bond length. A single bond is the weakest type of bond. You know, like how in middle school you were slow dancing, it kind of looks like that. And a double bond kind of has medium strength, you know, getting to freshman, sophomore year. And a triple bond is the strongest and closest bond, you know, like how seniors dance. The more appendages that are touching, like the more electrons that are shared, the closer your bond is. This also relates to bond energy. When you're forming a bond or dancing close, you get really hot and sweaty. Remember those cafeteria windows at homecoming? Because a bond is being made, it's an exothermic process and heat is released. When you're leaving the dance, you're breaking the bond, therefore it's an endothermic process.
Hey, Carm. You know, I've been thinking a lot lately. Even though you're not as smart as me, I think I can look past that and ask you to prom.
Really?
Only if you can answer this chem problem. Which Lewis structure of H2SO4 is more appropriate to draw?
I think you should worry about how nice I look in a prom dress.
We could get there, but answer the question.
You know, I would, but I don't know what that is or what you're talking about.
I don't think it's gonna work out.
Ryan was asking her a question about formal charges, which makes sense because prom is one of the most formal things that we will do in high school. Formal charge equals the number of valence electrons minus 1/2 the number of electrons in a bond minus the number of lone pair electrons. He was asking her about H2SO4 because he knows it's a very stinky compound and he doesn't want her to stink dancing with her. As you can see, there are two ways to draw H2SO4. One with all single bonds, or the other with two double bonds on the oxygens. You can also see me writing out how to use the formula, and it really is fun and easy, just like my coach Fabish enjoys to say. Now, to choose which Lewis structure is the correct one, you want the one with the lowest formal charge. And if two Lewis structures have the same formal charge, you choose the one with the negative formal charge on the most electronegative atom. This led Carlina and I to choose the H2SO4 on the right.
I figured it out.
You did?
Yeah.
I always knew you were smarter than I thought you were.
Really?
Yeah.
You figured it prom now?
Yeah.
You're insecure.
Stop, I have acne right now. Go. What chemistry fix that? Quiver. Ow!
Don't need makeup.
And that stuff is like the stuff.
Be the way that you are.